All right, guys, welcome to 10.3. This is limits at infinity and other oddities. From our study of asymptotes, we learned a couple of important things. When x is equal to c, this is a vertical asymptote of the graph of f of x. When y is equal to c, it is a horizontal asymptote of the graph of f of x. And for example, find the asymptote's behavior about the vertical asymptote and the end behavior of the graph of f of x. So if you were to graph f of x is equal to 1 over x minus 3, and I'm just going to draw a little picture of it here. At x equals 3, there would be an asymptote. And so this half would look something like this. There'd be a vertical asymptote at x equals 3, and then there'd be a horizontal asymptote. And I already put these here for the horizontal asymptote so we remember how to find them at y equals 0. And again, you could graph this, but it's just kind of being able to understand how you can see these things without having to graph it as well. So it won't cross the x-axis, and then at x equals 3. I'm sorry, the x-axis, yes. All right, so the limit of f of x as x approaches 3 from the left is going to be negative infinity. Why? Because from the left, as we go towards 3, it's just going to go down and down and down and down towards negative infinity. All right, the limit of f of x as x approaches 3 from the right is going to be positive infinity, because as we approach 3 from the right side, it's going to go up, 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 up. All right, and then the limit of f of x as x approaches negative infinity is going to be 0. Because as we go left towards this negative infinity, we're just going to get closer and closer and closer to 0, but we'll never actually touch it. And then the limit of f of x as x approaches positive infinity is also going to be 0, because we are just going to get closer and closer and closer to the axis, but we're never going to touch it. All right, so these are just things to help you kind of understand limits and how to identify them without graphing. All right, so limits at infinity can be found by looking at the end behavior of a polynomial and looking at a horizontal asymptote or looking at the graph of the equation. So we're going to find the limits at infinity for each one. And again, you can graph them and see it, or you can just have an idea of what it's going to look like. It's definitely always best to look at the graphs. That's going to help a lot. This is an x cubed minus 2x plus 1. So I know it's going to look something cubic like this. Because of that, this is how we look at end behavior, which is one of the things it said to look at. And this is a cubic function. So the limit as x approaches infinity, which is going to be, let's say, this way, is going to be infinity. All right, and then let's move on to the next one. So we're just talking about the limit as x approaches negative infinity of 2x plus 5 over 3x minus 1. So this is a rational function, and again, you can graph this. But here we're going to look at the horizontal asymptote. We need to find it first. So since these are equal, it's going to be horizontal asymptote at x equals 2/3. And so that our limit as x approaches negative infinity is going to be 2/3. All right, the limit as x approaches infinity in sine x. So if you were to graph this, it's going to look something like this. It oscillates. Oscillates being a key word here. That means that the limit of f of x as x approaches infinity does not exist. And we're going to talk more about those rules on the other side, but because it oscillates, the limit does not exist. All right. Moving on to the next one. We have 2x squared plus x minus 3 over x plus 1. So there is no horizontal asymptote, but there is a slant because the exponent on top is 1 greater than the denominator. So the slant, you would have to divide the top by the bottom, but that slant is going to be at y is equal to 2x minus 1. And again, you use long division or synthetic to divide the numerator by the denominator, and you would get 2x minus 1. From here, the limit of f of x as x approaches infinity of 2x squared plus x minus 3 over x plus 1 is equal to infinity. And again, we can look at end behavior here, because when we graph it, if I remember correctly, this is the asymptote, and so it's something like this, and it just continuously goes. So as we approach infinity, it will be infinity as well. All right, the limit of e of x, e to the x, times sine 3 pi x. So this is something you would just definitely graph on Desmos. It looks really, really odd. The one I graphed, it like oscillates and then it just dies into the x-axis, but keyword being that it oscillates. So because of that, the limit of f of x as x approaches negative infinity does not exist. All right, limit of e to the x. We've looked at this graph before. It looks something like this one here. All right, the limit of e to the x as x approaches negative infinity. So as we go this way, it's going to get closer and closer to 0. All right, and this is part 1 of limits at infinity.